Earlier classes we studied how to write Verilog programming. Then we studied how to write the test bench program for the given programs. So now what we'll do, let us study some of the basic concepts in Verilog HDL. So in the basic concepts we are going to study, then some of the data types we are going to study, then what are the basics of Verilog HDL is already given, but as per the syllabus, let us go. So here the first thing is let us study about the concepts here, the lexical conventions. Normally the lexical conventions used in the Verilog HDLs are similar to C programming. In the C programming also you use the lexical tokens. The Verilog also contains some scheme of tokens actually. The tokens can be like comments, delimiters, numbers, strings, identifiers and keywords. These are things how we'll represent in the Verilog as like in your C programming. And also, as I said earlier, the Verilog HDL is a case-sensitive language. This already we specified. So now all the keywords, whichever you are using in a Verilog must be a lowercase. That is very, very important. Now we'll see, let us see what are the different types of lexical tokens, or we can call lexical convention. This is the one of the important question in the examination. They may ask what are the lexical convention and what are the different lexical tokens are available in the Verilog HDL. These are the list were given. The lexical conventions are the white space, comments, operators, the number specification, strings, identifiers, keywords, and escape identifiers. These are the some common lexical convention we use in the Verilog HDL. So as we say, what is the white space? So like you might have studied in the C programming. If you want to use some any blank spaces, you must use slash backslash b. You have to use like this. So in C programs also you might have studied like this. Slash b represent blank space. Slash t represent tabs. The slash n in the sense it's like a new line. Normally, why we need to use the white space? The white space will be ignored by the Verilog except when separates the token. So normally the white space will not be ignored in the strings, in the white space actually. Let us see some of the example how we will use the white space here. You see the example like bad code I can say. I'll say some two things. One is like the bad code, another one is the, how it will be like a good code. When I try to write, you should not write like this bad in this like you write the program no module. This is the module name followed by inputs A, B, C in some semicolon. Input A, B, C, semicolon. Again, continue with the output. See the wire. See, we are writing in like a lines, everything. You should not write in this way. You have to keep some white spaces over there. That is what this. See, this is the some good way to write the program. This is what we did earlier. Module, the add bit module is A, B, C, some CO, then input A, input B, input C. As I said earlier, if the input is scalar, you can list individually also input A, input B, input C. If it is here, all three variables are scalar, you can represent input A, B, C also. Already we wrote that. Next output, then wire. This is the one some good code. That's nice way to write the code. The second lexical convention is comments. As we know that how we use the comments in a Verilog, we may use like in your Verilog program. The comments can be inserted in the code for readability and documentation purpose we use. Say I want to use something like what is this line space for, or I want to give some details. So further what you can use the comment. Here some two different types of comments are there. The one that way is you can write if it is a one single line comment, then you can start with the double slash like this. You can start double slash. You can do like this. You can do like this. Say the Verilog skips from that point to the end of the line. So if you are writing something like if you are writing something like this, welcome to Verilog HDL. Then what happens? This when you are compiling the line, this will skip this line normally. That is the point end of the line because at the same time this is for single line. If you are having multiple line, then at the time what you have to do in the sense multiple line will be like this. Multiple line when I write. So as C program scheme, you have to start with the single line. Then you have to give the star. Then you can write something. You can write welcome to Verilog HDL multiple line. So then again put the star, then close this. So like this you have to start with like this and you have to end with like this. This is the way you have to do. This is for multiple, this is for single line. This is the comment actually. So however, the multiple lines comments cannot be nested. It is very important. But our one lines comments can be embedded in a multiple line comments. So these are the examples. See, here we have shown A is equal to B and C. We used single. See, we used to see this is nothing but one line comment. See, this is the multiple comment we use. This is a multiple comment. So even this is illegal. See, which is showing here. This is illegal actually. Like one backslash star. This is again back star and illegal star. You should not use like this. But this is a legal comment actually. See, star. This is a slash a legal comment star slash. You can use like this, but in between you should not use in this way. These are the comments. Next, the operators, they're very important in the Verilog. So you know that in your C language also you studied the operators. Even the Verilog also has some operator. Here the operators are three types. The one is nothing but three types. The one is unary type, next binary type, third one is ternary type. Unary, binary and ternary type. Normally the unary operators precede the operand. That is the first you will have like this what single operation. Example for unary operators is this will have precede in the sense A is equal to not B. See B, it's the precede one operator is that this is the unary operator. It perform only one operation. That is what only one variable we are having. So that will be like single variable we may use. So B is a operand, or we may have single operand. That is also I can say. It's a not only one symbol, so I can say it is a single operand. So only we are saying unary operator. Next, binary operator will be appears between two operands. Between two operands in the sense, see, this is the binary operand. The binary operand will produce the output, the binary values like either 0 or 1. See, A is equal to B and C. See, here we specified this double ampersand is a binary operator. But the B and C are operands actually. It will perform the AND operation. But earlier we studied for AND operation, we used only one single ampersand we used. But here I am showing as double ampersand. That is not the issue. Both will work fine. Even if you use single ampersand or double ampersand, it will give you the output. This is the binary operator. Then ternary operator. The ternary operator means have two separate operators that separate three operands. That is two separate operators will be there that will separate the three operands. So what is the example in the sense here? A is equal to B. See the question mark C colon D. Now you need to see how this will work. The question mark and semicolon, you see this question mark and this semicolon is a ternary operator. This only we can call as ternary operator. Question mark and a colon. Then B, C and D are operands. How the syntax will be this? In the sense, very simple. See this, the syntax are given for ternary operator will be condition expression. Which is condition expression? This only. This is the B is a condition expression. I can see simple. Question mark, true expression, colon, false expression. What is the meaning of this here? A is equal to B, question mark, C, colon, D means if this B is true, then C will be executed, else D will be executed. That is the meaning of that. Means simple, I can say this is true expression, this is false expression. So simple, I can say A is equal to B. B, if it is true, C will be executed. If it is false, D will be executed. So simple, I can say 1 means C, 0 means D. So this will be one of the very special operator we use in our Verilog to minimize your code. Normally, you can write the multiplexer code using this itself within a single line. You can write multiplexer. Example 2:1 multiplexer. You can see. So how we can write multiple example? I will show the multiplexer how we can write here one simple example. Y is the output. Y is equal to, we can see selection line, right? Selection line, I'll put a question mark here. I'll put a question mark. Now you can see if the selection line is 1, what it will select? It will select B. Correct? If selection line is 0, it will select A. See, this is what simple I can say. So if the selection line is 0, true, means if you select B, means how it is, you can see like a if statement. You can go for if statement. The 2:1 multiplexer. How you can write using if statement? If selection line is equal to 0, A will be selected. If selection line is equal else, B will be selected. That is what we written in a single statement. You see, the same like this you can write in a for 4 marks. Also you can write. This is what the operators. These are still so many operators are there, but as of right now we are seeing this one. I hope this operator you might have understood the ternary operator very clearly. Next, the number specification. A very important thing in the Verilog, the number specification. How we are going to specify the number? Here, there are two different types of number specification is there in Verilog. That is, one is sized number, another one is unsized number. One is sized number, another one is unsized number. See, we are having sized number and unsized number. Size number in the sense we need to fix the radix like a 2-bit, 3-bit, 4-bit, 5-bit, 6-bit, that we need to specify. Unsized in the sense even though if we not specified, the system will take by default the number size will be unsized. Example, let us see which is we can say sized number. Normally the size number how we will specify in the sense this is the syntax actually. Size one single quote. This is the base format in which base we are going to say. Example, I can say the base in the sense binary, decimal, octal, hexadecimal. In which base we are going to do. Then respective number already we written. You hope you remember 2-B00. That is the example I can say. Size number. The size is written only in decimal. Very important. See, the size you need to write only in the decimal and specify the number of bits in the number actually. The legal base, this format as I said, you can say decimal, hexadecimal, binary or octal. You can specify in any way, either lowercase or the uppercase. Next, the number is specified as consecutive digits. In the sense here, like a 0, 1, 2, 3 up to hexadecimal numbers. These are only subset of this digits is legal for particular base. Like in the sense, if it is a decimal, it is valid for up to 9 numbers. If it is a 9, not only 9, 10, 11, 12, you have to write like this. If it is octal, you have to stop up to 7 only. After 7, like you can write, it won't go beyond that. If it is a hexadecimal, you can go from 0 to F. Very important, uppercase letters are legal for numbers. Uppercase letters also you can use here. See, this is the example here we are showing. The first example you see, 4-P11. This is a 4-bit number. Now 12-HABC, you see, like 12-HABC, this is something about hexadecimal number. H is a ABC, A 4-bit, B is 4-bit, C is 4-bit, totally 12-bit will come. 16-D255. Simple I can say, it is a 16-bit decimal number. The 255, how we can specify? It's a, in the terms of binary number bit, 255 will be normal, 255, decimal 255. We can represent with the 8 also, we can represent with 16 also. But here we are saying yes, 16. Next, 4-B10. This is a binary 4-bit number. Here you see 5-D3. This is 5-bit decimal number 3. The 3 you need to specify the 5-bit number. So how can I represent in binary format this number? I specified in decimal. So it's supposed to be 0, 0, 0, 1, 1. You can specify like this. Then you see here one thing is differently is there. 3-B01X. Now you see a 3-bit number with at least significant bit is unknown. Which is significant bit is unknown? This X is the unknown number. So as I said, the Verilog will support totally 4 values, right? Which are the values? 0, 1, X, Z. 0 is logic low, 1 is logic high, X is unknown, the Z is high impedance. Now second here another example, 12-HX. So it is nothing but X will be 12-bit number. Here outward 12X will be there. hexadecimal, unknown number, it's unknown number actually. So 16 dash H is it is a 16-bit high impedance number actually. So these are all sized numbers. Now let us see how to specify the unsized number. So here the numbers are specified without a base format. See, the very important. Without a base format, the specifications are decimal numbers by default. Example, we can say the numbers are written without size. Specify have a default number of bits, that is simulator message just like I can say minimum 32. I can say if you not specify the size, the system will consider as like the minimum, the default number will be 32. Then if you not specify the base format, in the sense whether it's a binary or octal, hexadecimal, if you not specify that, by default it will be decimal number. Example, you see, if I say write like this 2 3 4 5 6 number, if I write, so the system will consider this is a 32-bit decimal number by default. Why? Because I am not specified how many bit, then I am not specified whether it's a binary or decimal. So by default the system will specify is what? 32-bit decimal number. See here, you can write dash HC3. I am not specified here the size. What is size? So if I not specify the size, what it will do? It will take us by default 32-bit. But I specified the radix here. See, radix is there. So it is a 32-bit hexadecimal number. Same even here also. What is this now? It is a 32-bit octal number actually. Then you can see dash 659. What is the dash 659? So dash 659 is dash 659. Here we are not specified the size as well as we are not specified the radix. So by default it will be considered as decimal number. Next dash H S837FF. So here we are not specified the size, not specified, but we specified the radix. So by default we will consider as what? 32-bit hexadecimal number. It will be considered as like this 32-bit by default. 30-bit, right? 4 4 4 4 4. Totally it will be considered. You don't think here I wrote only 5 for the 20-bit, so it will be considered as 20-bit. No, by default it will be 32. Same this one also. See, all are. But you can see here this is a illegal because hexadecimal format requires H. Here what did happen? Dash 4A F we said. I'm not specified which. If there is no F, there is no A, then it will be considered as decimal only. But AF is the system will not consider. By default it is a hexadecimal. It cannot be decided as a decimal also. It must be H is recorded here. Then only it will be considered as hexadecimal. So that is nothing but your unsized number. Now the another two values, X or Z values. The Verilog has two symbols for unknown. This is X. Then this is high impedance is Z. Now these values are very important for modeling a real circuit. When you are going for real circuits, only these things are required, because we cannot say when you are working on the reality, sometimes there will be unknown signals will be there, sometimes high impedance signals also will be there. So the unknown value will be denoted as X, then high impedance value denoted as Z. Then the example, see, same 12-H13X, nothing but it's a 12-bit hexadecimal number. Very important, you see, 4 least significant bits are unknown. Which one? This only. It's a unknown actually. Now 6-HX. The 6-H is nothing but 6-bit hexadecimal number. 32-BZ means 32-bit binary high impedance number. See the example, the program how we build register 11:0. This is, don't think it belongs to which program. It's a simple example written register 11:0 A. Then initially we return, then begin, and in between statement A is equal to dash HS. What is this actually? A is equal to dash HX in the sense we are not specified the size here. Correct? Now you should say it belongs to how many size now actually. But you see register, remember here we declare register. The register has how many bit? It is a 12-bit. A is a 12-bit actually. So now A equal to dash HX in the sense what will happen? It yields all the values are X. In the sense, complete bit will be XXX. Now come to here. A is equal dash H 3x. If I write like this, because 12 bit, okay, here. So let me write how it will be. Here, how it will be? A is equal to, the result will be x, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because of we registered 11 colon 0. Next, here, how it will be? A is equal to H3x is there, right? Here x is there, here 3 is there. But if I say 12 bit, and this is how it will be. This is 4 bit, this is also 4 bit. So 4 for 8 only is there, but A is 12 bit. So by default, how it will be in the sense 0, 0, 0, 0, 4 zeros, then 3. It is like how it will be 0, 0, 1, 1. Next x, 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 x. This is what the value come actually. Next same here. How it will be this? This will be A is equal to, any idea? Can you say what will be? Anyone can say how the number will come now?
Sir, 8 zeros, sir.
It is total
8 zeros and then
yes,
XX.
1, 2,
8 zeros
3,
stand for X.
X. So 8 zeros, last finally X, 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 X. Yes. I hope you understood this, right? This will be the result. It reads the result as like this. So simple, we written it here. This is nothing but using X and Z. This because here is specific. This is an automatic extension of X values. Automatically get extends actually. So now here I can say an XOR Z sets 4 bits for a number in hexadecimal bits, 3 bits for a number in octal bits. This is already we know only. So now here say this also we know nothing. So very important. If I add this x, the x position automatically get extended. How many bits is that? That will be extended. Even if you write like this, y is equal to 12 dash h1 h0. If it is like this, then what is the result? Will be 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. It will be like this. That is the meaning of that. Automatically it will take. But you cannot say this is like this. 12 dash H1. H1 also it will be filled with all or ones. But that will become as wrong. Very clear. Only for 0 it will be 0. Even for X will be X. Then Z also will be Z completely. But if I go for 1, automatically what will happen? 1, 2, 3, 4, 4. It will be like this actually. So this is the difference actually how we are going to get. Now, how we are going to specify the negative numbers in the Verilog? How we will specify negative numbers? The negative numbers can be specified by putting a minus sign before the size of the constant number. See, the size constants are always positive actually. Whichever the number we wrote earlier, everything is a positive number. You need to specify the negative. So it is illegal actually. See, it's illegal to have, it's a illegal, very important this. It's a illegal to have a minus sign between the base format and the number. An optional sign specifier can be added for signed arithmetic. Example, see here. Example, these are the examples here. You should just you are add one extra minus here. Minus 8-D3 represents what? It is a 8-bit negative number stored as 2's complement of 3. That is very important because of negative. Because of negative, it is stored as 2's complement of 3. Minus 6-SD3. What is this? It's nothing but it is used for performing signed integer. See this S. This S indicates the signed integer math actually. But this is illegal. See, there is no minus between the format D, the number. This is the base radix format. You should not write like this. Then this will become a illegal specification. That is the reason always you have to specify the minus in the previous year. Like this, you have to specify. Same example, this illegal syntax. See, 8-D space minus 6. This is a illegal syntax. Then minus 8 D6 is the legal syntax. So this defines 2's complement of 6. That is nothing but held in 8 bits equivalent to minus 8 dash D6. So very, very important. If this minus is not there, that will be considered as positive number. If there is a minus in the previous, then that will be considered as negative number. So like this only you say. Then the underscore character and the question mark. So the underscore character also we can use. How we can use underscore character here? And underscore character is allowed. This one. The underscore character is allowed anywhere in the number except the first character. See, very, very important. So when you are writing the binary number, octal number, or hexadecimal number, anywhere the number you can use the underscore. Why? Because if it is a 16-bit number, all 16 continuously if you write, you may get the confusion. We need a separation for 16-bit number by you need to write 4-bit, 4-bit, 4-bit. So how can I write in the sense? It will be very, very easy to elevate. So the examples, I'll say for example, use that. See here. See how we written. Actually, it's supposed to be written as like this. It's supposed to be written as like this.
1 second. So Miss Nale ಮಾಡ್ತಾನ ಅಂತ ಕೇಳ್ತೀನಿ.
ನೀನ್ ಬರ್ಬೇಕಂತ ನಾಲ್ ಮಾಡಿಸ್ಲಾ ಕೇಳತ್ತಾನ. ಮಮ್ಮಿ ಬರ್ತಾರಂತ ನೀ ಬರ್ಬೇಕಂತ.
ಹಾ ಸರಿ ರೆಡಿ ಆಗ್ತೀನಿ.
ರೆಡಿ ಆಗಿದೆ ಬಾ.
See here. This actually supposed to be like this 12-B111. See, if it is like this, then it is very difficult for us to read the number how it is. So instead of that, even we can separate it. How can you separate in the sense? Like say example 4 ones. See, I can separate like not only like this also. Even if you want to separate, you can separate like this also. B111. You can separate. But if I separate like this, what will happen? It becomes 3-bit. So because of 4-bit, it will be easy for us to read. Even we can write anything, not only 4-bit, 4-bit, 5-bit, 6-bit, it is for us. So it is used for underline the characters for readability, only for readability. Then second one is question mark actually. So the question mark character is a Verilog HDL alternative for Z character. See, for Z character, the question mark also can be used. Also used, so it sets 4 bits to the high impedance value in hexadecimal. Actually, the question mark is used to enhance the readability in cases where the high impedance value don't have condition. High impedance or don't have. See example 4-B10 question mark. It is nothing but equivalent to 4-B10 is that. So either you can write like this or you can write like this also. The system will consider us like this. The very important thing in the Verilog is we have size very important. See, a size negative number is not sign extended when assigned to a register data type. If you are assigning to the register, then the negative number is not signed extended if you are doing in the registers actually. So later we will see those things and all. See the another example. See, these are the some simple ways you can use the underscores between the numbers. See, 27_190_. This is what is this now? Can you say this specification now? Previously said sized, unsized. Now you say what is this? Anyone? 27_190_000. What is this? How we can represent this? It is a 32-bit decimal number. Is it correct? Is it correct?
Yes sir.
It's a 32-bit decimal number. Here the size also is not specified. The radix also not specified. They written only the number. Then what the system will consider? The system will consider as by default is 32-bit. Then by default is decimal number. Then second here you see this is simple 16-bit binary. Here this is 32-bit hexadecimal number. This one is right. This is a 32-bit hexadecimal number. This is 32-bit hexadecimal number. The next will be string. So normally in your C programming you studied the strings. So even here also Verilog we are having a string. The string is a sequence of characters that are enclosed with double quotes. Like say example, if you use like this, should be same considered as a string actually. The restriction on the string is that must be contained a single line, very important. That is without a carriage written. The sense you should not contain like the continuity with the next line. You should not have. It must be a single line. It cannot be on multiple lines. That is what I said. So the strings are treated as sequence of 1 byte ASCII. The strings are sequence of 1 byte of ASCII values. The string values should be considered as like this. How in the sense that is the Verilog treat the strings used as operands in expressions and assignments as a sequence of 8-bit ASCII values with one 8-bit ASCII value representing one character. Remember, when you are writing any string, each character will be represented as 8-bit ASCII value. Now example here you see, example is hello string world. See, hello Verilog world within the double quote. It is a string. This is a string. Now you can see this also string. Double quote A/B with the double quote. So even this also string only. Then double quote, this is string, even this also. Now print out a message slash and even. See, remember this you might have written in your C programming. You hope when you are writing in the printf statements, whatever you write within the double quote that will be printed on the display screen. Same even here also. That is what we can say string. So now the next is the string variable declaration. The string variable declaration in the sense like how we can declare a string in the variable, like to declare a variable to store a string, because here we are going to say it's a string. String in the sense I need to store here all the values are binary hexadecimal. So for each and every character is 8-bit ASCII code. So now how much string you are going to store? So that much the size of the array you need to declare. So now for what you have to normally to declare a variable to store a string, declare a register large enough to hold the maximum number of characters the variable will hold. Very, very important. I doesn't know. Example, I can say one simple. If I want to say, let me say as Verilog. Okay, you take consider as Verilog within the double quote, or within double quote I say hi. Now how much the space is required? The string, how much the memory will take? Each character is 8-bit ASCII. So in the sense 8-bit ASCII code in the sense it is a 16-bit. So how can I need to declare a register here, range. I need to say it is nothing but what I should not go for exactly the same. It is 17. What I will do normally, I'll go for like this 8 20:0 something y. So if I do like this, I'm going to store this string. I'm going to store this string. I'm going to store the string hi in the variable y, which has 20:0, but the 20:0 is more enough actually, because I required only 8 plus 8, 16 only. So very, very important, you need to give more. That is what here the specified, hold the maximum number of characters the variable will hold. So note that no extra bits are required to hold a termination character, very important, which is if you are having a semicolon, so no need any extra bits for the Verilog does not store a string termination character, the Verilog actually. So for example only here we said, for example, to store the string hello world, see hello world, here we say an example with the exclamatory mark. So it requires the registers of how much registers required. For each character is one 8-bit register. So totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 we may think. But there is a space is there, that also will be considered here. So it's 11, then on exclamatory mark 12. So totally 96 bits is wide. So how can I write this now? So I will be written as I want to store this hello world. So how much is required? Say example here, the example is here. See, register 8 cross 12. I can write 8 star 12 also, or I can write 96:1 also. Anything is fine. The register name is string variable. Initial, begin. The string variable can be stored the hello world because of the string word has enough of 96:1. Even you can go as 100 or 128:1 also you can go. So as much sufficient storage is needed to store the strings. That is very, very important. I hope till now it's very clear for you. Is there any queries or any doubt in this?